Fundamentally, chemistry is a study of matter and its properties. In this video, we look at identifying and characterizing both physical and chemical properties of matter. So chemistry is essentially the study of matter and how different types of matter interact with each other and how matter interacts with energy. In terms of understanding what matter is, for our purposes, we are talking about baryonic matter. That is matter that is made up of baryons, fundamental particles such as protons and neutrons. And we will learn a lot more about these fundamental particles a little later on. What we're talking about is everyday matter, matter that can be readily observed by our senses and can be readily quantified or measured by taking measurements. We are not talking about the 95% of matter that makes up the universe that consists of dark matter and dark energy. Whilst there is evidence that dark matter and dark energy exist, we can't physically observe them with our senses. We can't use physical tools to make direct quantitative measurements of them. And these ideas actually help us to define the type of matter that we are interested in. As far as we're concerned, matter is anything that occupies space and has mass and can be perceived by our senses. I like this definition of matter because it brings in the observational aspects of science as well as the quantitative aspects of matter being able to be measured. For example, we can measure mass of matter and we can measure the volume of matter and we can directly observe it using our senses or by utilizing tools or instruments to assist us. So whilst we are gaining an understanding of what matter is, it's important to know what it is not. And matter, for the purpose of our chemistry studies, does not include forms of energy such as heat or light or electrical energy or any other forms of electromagnetic radiation. So microwaves, X-rays, visible light, radio waves, etc. are not considered forms of matter since they have no measurable mass and no measurable volume. So whilst these forms of energy are not considered matter for our purposes, they are nevertheless important because chemical transformations of matter and physical transformations of matter often involve the absorption or the release of heat, they often involve the absorption or release of light, and they often require or produce electrical energy. So the way that matter interacts with these forms of energies is important to us. Before we look at physical and chemical properties of matter in detail, it is worth considering what we actually mean by the term properties of matter. Properties of matter are characteristics that allow us to recognize, identify, or describe matter. And then, once identified, these properties become very useful because they allow us to distinguish one type of chemical substance from another type of chemical substance. Now, we will go into chemical substances in much greater detail in following videos. But for now, it is useful to understand that a substance refers to matter, or a piece of matter, that contains a unique set of physical and chemical properties. And chemical substances can be classified as either compounds or elements. It's generally thought that if two pieces of matter have the same set of chemical properties and the same set of physical properties, then they are in fact the same substance. They are the same compound or they are the same element. So identifying the physical and chemical properties of matter is a very good way of identifying what type of substance we have. And so, in order to identify substances, we need to get a handle on the properties of matter. And we just alluded to this. There are two types of properties of matter. There are physical properties of matter and there are chemical properties of matter. Physical properties of matter are characteristics of matter that can be observed without changing its chemical identity or chemical composition. Chemical properties, on the other hand, are characteristics which describe the way in which matter may change or resist change from one substance to another. We'll start with physical properties of matter, characteristics that can be observed without changing the chemical identity of matter. And the physical state that a piece of matter exists in is a physical property of matter that can be observed without changing chemical identity. So when we heat solid ice, for example, and it melts to liquid water and then evaporates to form water vapor in the gaseous state, we are not actually changing the chemical identity of water. And so whether water or any other substance is in the solid state, the liquid state, or the gaseous state, that state is a physical property. The boiling point of a substance, the temperature at which a substance boils at standard atmospheric pressure, is also a physical property. So too is the freezing point, that is the temperature at which a substance freezes. That freezing point temperature is a physical property of matter. It's important to note that both these processes, boiling and freezing, do not create new substances, and therefore the boiling point and the freezing point can be observed without changing chemical identity. This makes them physical properties of matter. The colour of a substance is another property we can observe without changing its chemical identity. Colour is therefore a physical property of matter. And the density of a piece of matter is also something that can be observed or measured without changing chemical identity. We can measure the mass of a piece of matter and we can measure its volume and therefore derive the density without changing its chemical identity. And finally, in many cases, the solubility of a substance, that is how much substance can dissolve in a particular solvent, can also be observed without changing the chemical identity of either the solvent or the solute. And so, in many cases, but not all, the solubility of a substance is also considered a physical property. So all of these properties can be observed or measured without changing chemical identity, and all are therefore considered to be physical properties of matter. Chemical properties of matter are characteristics that describe how matter changes or resists change from one type of substance to another. And one example of a chemical property would be flammability or combustibility. Here we see the burning of natural gas or methane in the presence of oxygen to produce two new substances, carbon dioxide and water. So if we say something is flammable or combustible, that is a statement of a chemical property of matter that describes how that matter changes from one or more types of substances to new types of substances. And in this case, that change happens to occur with a concomitant release of light energy and heat energy. Oxidisability is another chemical property of matter. If we leave a piece of iron or steel outside exposed to the elements, then it will eventually rust, and that is a chemical process. The oxidisability of iron, which in the presence of oxygen can produce iron oxide, is a chemical property of iron that describes how it can change to form new substances. The inertness of a substance is also a chemical property that describes how matter can resist chemical change from one substance to another. Helium is an example of a noble gas, and along with other noble gases such as argon and neon, helium does not, as far as we're concerned, chemically react or undergo any chemical change to form new substances. So when you try to react helium with anything, you won't generally see a chemical reaction, and this resistance to change, this inertness, is also a chemical property that can be used to describe matter. So flammability, combustibility, oxidisability, and the inertness of a substance are all chemical properties. All are observed or measured by identifying whether a change in chemical identity has occurred. In summary, physical and chemical properties are characteristics that fundamentally allow us to recognise, identify and describe matter, and most importantly, they allow us to distinguish one type of chemical substance from another. Physical properties of matter are characteristics that can be observed without changing its chemical identity, whereas chemical properties are characteristics which describe the way in which matter may change or resist change from one substance to another.